whatever app they use.
Welcome, everyone. So today we have Jerry Ropelato, who's going to talk about 3D printing. Jerry.
Okay. Pleasure to be here, guys. So you guys are already asking lots of questions. That's what I wanted. I haven't put together a formal presentation. We're going to make this very casual, enjoyable. I want you guys to ask questions. No question is too dumb. So let me tell you a little bit about White Clouds, how we got started. So I'm the CEO of White Clouds 3D printing company. Welcome, guys. Oh, man. Man, they'll just let anyone in here, won't they? Oh, my gods. So we're a little over a one-year-old company. We spent the first 8 months of our existence just doing R&D, trying to figure out how to get the equipment purchased, how to get it installed, and how to use it. And then, more importantly, how to get good at it. And it took us a long time. So, a lot of people think you can go buy a 3D printer and, really be kicking out some great quality products in a matter of days. It ain't going to happen. There's a lot of tricks to the trade, as we've found, and we're still learning new things every day. And so it's a fun company, about 20 employees based here in South Ogden. I thought what I would talk about today, well, first of all, let me say this. If you guys have a question, stop. I'm here to answer your questions. I'm going to talk a little bit about the industry, where it's at. We'll talk some about some of the prototypes I brought here. So 3D printing, let me back up and give you a history lesson. First of all, let me say this, guys. So I think you guys are all coders, right?
Well, it's kind of a mix, entrepreneurs, designers, developers.
Okay.
So.
Well, for you coders, so I started coding in 1975. That was back in the days of Assembler, COBOL, Fortran, RPG. Those are all like swear words today. I have published a Java book, so that was the last language I really got involved with. I suspect some of you guys do PHP. I've never written a line of PHP code in my life, but I think I've picked it up. I can pretty well read it, and so I've got a strong coding background. But my kids now call me the user. That really hurt the day that happened. But so we've got some things in common here. So anyway, I want to go back to the mid-'70s. So this is when I was starting out in programming, just getting into computers. 1975, give or take a year. If you go back, that's when the first personal computer was built. Do you guys know what it was? PC Altair. PC Altair was the first computer. When that computer came out, the industry as a whole was about 30 years old. So you had the big iron players, the IBMs, the Burroughs, the Honeywells. So the industry had been around for a long, long time. But what changed it forever was the personal computer. And where consumers could now use this, you had the Apple come out right after that, a number of other products, and changed the industry forever. 3D printing is the exact same scenario. So if you look at it, here a couple of years ago, you had these consumer models coming out. The MakerBot is probably the most prevalent. It wasn't the first one, but it's by far the most popular one today. The industry as a whole has been around for 29 years. So a lot of the technologies that still exist today, still being used, started 29 years ago by Robert Hall. What's interesting is this year a number of the patents are expiring, which I'm hoping will kind of spur some interesting new developments. Even though the patents are old, there's some underlying technologies that to even be able to prove on those technologies are patent violations. So some interesting things happening there in the marketplace. In all reality, in my opinion, there's probably 3 or 4 major players. So I'm going to get out of the consumer world, because in all honesty, the consumer world today is just like a drop in the bucket. So you've got Stratasys, 3D Systems, X1, and EOS out of Germany. Those are probably the big four. There's a fifth one, matter of fact, and I didn't even check the stock price today because I'm waiting for it to drop about 50 cents, then I'm going to buy. And that's called Ogden. Ogden Ovo. So they're based out of California. I truly believe if they can stick around as a company, because I think they're using up a lot of cash. They're a public company. I truly believe if they can just deliver on a couple of these things, it's going to revolutionize medicine as we know it. So they're the company. That's why it's called Ogden Ovo. They're the ones working on how are you going to 3D print a heart. A lot of cool stuff they've got going on in their industry. So I kind of mentioned them, even though they're not a manufacturer per se. They're the other public entity out there doing some real interesting things with R&D. So those are the players. Then you've got the consumer space, and in all honesty, you've probably got two that are what I would call the dominant ones: MakerBot and the Cubes. Cubify is their website, which is interesting because they've now both been acquired by 3D Systems and Stratasys. So they're part of those groups. As of today, I'm guessing there's 170 manufacturers of 3D printers in the consumer space. There's probably one or two new ones every single week coming out. Fast forward to a year from now, I think you're going to have, you'll probably have 150 out there, but I'm guessing you know, the 20 that go by the wayside, the other 146 should go by the wayside too, because they're not going to make any money. It's not going to be a sustainable business. They don't have anything unique, even though they'll probably still be alive working out of someone's garage. I just don't see the industry changing a lot with some of the major players. You've seen all kinds of Kickstarter campaigns going live. The last one, what they do, they did $3 million in the first 48 hours. The sub $200 3D printer. A lot of interesting things going on. You know, how they sustain a business model with sub $200, I don't know. The other thing I want to just mention about the industry is the new player that has announced they're getting into it is Hewlett-Packard, HP. So they announced about 45 days ago that June they would be coming out with their big announcement. And did you guys see what happened 24 hours later? Never seen this happen. They actually came out and rescinded what the CEO had made public. And they said, well, it's not going to be June, it's probably going to be towards the end of the year. You know, a miss of 6 months. You know, that was pretty big news there for a couple of days. You guys, many of you work in the computer industry, so what is uptime? What do you guys expect uptime to be? You know,
99 and a few nines.
Yeah, 99.99%. You know, that's pretty standard today. In this industry, 3D printers, a good rate would be 75%. So now stop and think about that. You buy one of these expensive 3D printers, that means a fourth of the year. So say what, 13 weeks, your machine is down. I think this is just my personal opinion, I think that's where Hewlett-Packard is going to come in. Hewlett-Packard knows how to do customer service. The other big players haven't figured it out. So your machine goes down, you might get someone on the line that day. You might get someone to kind of work through it maybe the next day. If it's a bad part, someone's got to fly out, you might get them there in a week. They've got to wait for the part. I remember we bought one printer, we paid $65,000 for it. On day 3 it went down, and it took us 21 days to get it back up and going. I was not a happy camper. Now, that was a learning experience for me. Hey, I'm in a different industry. Computers, 3D printers, really very different industries, and so that's kind of an expensive learning experience for me. And so, so that's a little bit about the industry. let me tell you what 3D printing is. You know, there's a lot of different technologies, and I'm not going to go over all the technologies, but at the end of the day, you pretty well look at it. It's like building a house out of bricks. It's just done layer by layer. That's really what 3D printing is. It'll take instructions from the software, and it'll actually just determine where it's going to print, and it just goes layer by layer. Some of it's round and round, some of it's one directional. There's different technologies that do different things, and so we'll probably talk about those, and maybe now's a good time to do that. So any questions so far, guys? You guys are pretty quiet. So here is an interesting model. I was told last week in New York that this is the most detailed 3D home model ever built. Right here. 3D Systems, which owns the actual machine that built this, said, yeah, there's nothing that's ever come out of our lab, and we've never seen anything like this anywhere in the world. So if you look at this, this here is a 14,000 square foot home. And just please don't drop it. You know, I'll let you guys pass it around if you want to take a look at the detail on it. That was all 3D printed with a printer.
Are they extruding all those colors, or is that
yes. So let's be very clear. Most people say, well, okay, so you had to paint that. And so as you look at the model, the colors come out. This particular printer, which is called a ProJet 660, the prior printer that was called a Z Printer 650, which is probably a little more popular. It's been around for quite a while. This will actually print 750,000 colors. So very much, you know, like a computer pixel by pixel type thing.
Them in the head, or?
Yeah, you know, as I was driving over here, I thought, why didn't we have this over at our facility? You could all then see the equipment running, and I thought, you know, I just didn't even think about it. You know, I've had a lot of tours over there, and I should have just had you guys come over. But this particular printer, it's very interesting because the powder, it's a powder-based. So you guys know what sheetrock is. So sheetrock's made out of gypsum. That's what this here printer uses. It's a gypsum powder combined with HP cartridges to bring out the color, and a binder element. And just kind of, as it's going back and forth, there's an arm that just goes like this, and it mixes it all in one layer each time. So something like this would have been probably about 1,400 layers. So 1,400 passes. That particular printer will print about 1 inch per hour. So, you know, it's probably 3 or 4 inches, so probably 3 or 4 hours to print this. Yes?
Yeah, I do have a question. I talked to Representative Strauss downtown about Mojo for type printer, and he basically told me just for one, refill bag, it's like $400, $5 an ounce, basically. But I do actually own a 3D printer now. But
so what have you got? Out of curiosity.
I've got an actual printer, or it's Print R.
Okay, right.
And I just got it just the other day and messed with it. But just looking around at the different types of printers, basically the extrusion that they use, I mean, it's just that filament.
Right.
It's very cheap compared to the $400 bag. You have to buy from them, or you just don't get it.
So let me talk about materials pricing. So you've got an FDM printer, fused deposition modeling. Okay, so it uses typically ABS or PLA materials, depending on which one. Of the 150 consumer 3D printers, there's probably only one that I'm aware of called Forms Lab that's actually doing some SLA stereolithography type printing, which is cool stuff. It's using lasers, but all the others are using FDM, or which would be very similar to this right here. It's kind of a hard plastic. It's a very different process than this. This one uses after you actually pull it out of the printer, you actually have to harden it up. So let me back up and say, when I pull this out of the printer, I'm taking my hands, reaching into powder, and I actually take a vacuum hose and kind of suck out all the powder. I'm kind of like an archaeologist. I pick it up, And I have to be extremely careful because it hasn't gone through what we call an infiltrant at that point to harden it. So we put it in another little workstation, kind of blow it off, and then we actually put what's really, it really is super glue. You know, it's very expensive super glue, and it actually hardens it up. And what I don't like about these models is if I were to actually take and slide that off the table, it would break. You know, from this distance, there's no doubt in my mind it would break. So they're very fragile. They're good for objects that might be on a particular table, you know, as a display type thing. If you're using them for any types of strength, it's the wrong material. So there are a lot of different materials. Let's talk about these. Let's see here. Did I actually? Actually, let's go here. I'm going to pass this around. So we were at Comic-Con here last week. We actually built this here for the convention. So this is some zombie scene. I'm not big into the zombie movies. Maybe you guys are. But what I want you to look at there's a lot of details. Every item on there is 3D printed. Now we actually combined items from 2 different printers. And so you'll see the broken glass there. That's actually from a different printer than what most of the color items are. Pretty cool, though, isn't it? The detail. So if you look at that, if you pulled out the clear glass, the rest of that was one print altogether. Other than the table, I think the table is removable there. That's kind of turned upside down. Some pretty cool stuff. You've probably never seen anything 3D printed like this. Yeah, I haven't, and you know, we pretty well know who's doing what, and so this was kind of a very unique model to just kind of demonstrate some of the cool stuff that you can do with 3D printing. Here again, same printer. We've done a lot. Hi, how are you doing? We've done a lot of printing with this. What I don't like about this particular printer is the post-processing is. Well, let me say this. It really took us 7 or 8 months to figure out how to do something like that without destroying it, without, you know, when you put the super glue on it, how you get big, huge puddles, and there's a lot of challenges with the post-processing. So when this actually came out of the printer, you might have still had another hour and a half of labor to actually get it to the finished product. And so some pretty cool stuff, isn't it?
So how many times did it take you to get it that good? Is that?
I would dare say we probably, you know, it was kind of interesting. One day we were just working and we all looked at the object that came out and we said, I think we're there. And I think up to that point we had probably printed maybe 700 or 800 different things. And so you can't underestimate the post-processing. I know a lot of companies are buying 3D printers. They want to use them for rapid prototyping. What we're finding is then they realize there's a lot of work. And it isn't something you can just spend an hour, you know, kind of I mean, you really need some full-time people, you know, figuring out how to use these. It's very complicated stuff.
That's a finished product.
It is. It is. And
whereas
so
usually when you're prototyping, you're going to cast it, or you're going to do something else. But that's done. That's amazing.
So I'm going to pass you a different one, and I think I'm under NDA. So I'm not going to tell you who or what or the circumstances. All I'm going to pass around is I'm going to say this is in an automobile, and they had to make some changes. And they actually built a tool through injection molding. And this particular company ran into some production problems, and so they came to us and asked us to 3D print. They asked us to print 9,000 parts of this here little tool. But I just want to pass it around and show you what an injection molding part and a 3D printed. So we did these here. We would print because it's a 2-piece set. And they had to put the pin in, and I wished I could tell you more about it because it's kind of a fun story. I just can't do that. But what I want to show you is that we'd print 300 of these in one single pass on a printer. And so why don't I pass those around? So the light gray, what color is that? I'm colorblind. This one, the green. There we go. Boy, that was pretty obvious, right? So this particular one was printed on a Conex printer. So this is a kind of a polyjet technology. I personally think this is the you know, the printer that we use for this here is about a $65,000 printer. This printer here, the first one we bought was about $250,000. The one we just bought last week was, I think, list on it's $360,000. So let me tell you, the printer that printed that, it uses ultraviolet lights. It will actually print actually that one printed 107 different materials, 14 at the same time. So it will print everything from rubber-like materials to transparent materials. This here was printed on it. So are these cubes were printed on the upgraded version of that, which is the color version, which prints 180 materials. What I don't like about the colors, it only has a 64 color palette, which is a little bit limiting. But that particular printer is awesome. So let me back up and say, how many of you guys have ever seen the Invisalign braces? Yeah, the clear braces. The entire company, Invisalign, creates all of those braces with the same printer that printed that. It's called the Conex. We own a Conex 500. It's the only one in the state of Utah, and we now have 2 of them. And so the new one we just bought prints the colors. And so I wanted to pass this around. It didn't break. So there are only 3 color printers on the market. And when I say color, sure, I can use FDM and I can print one color on it. A few of them you can actually stop the printer, put in a new spool, and then, you know, from the bottom to the next, yeah, you can do multicolors that way. There's really only 3 printers in the marketplace that can do colors like this, and so you've got this one, which is the Z printer. The drawback is it's real easy to break things. 3D Systems actually came out with another one that actually will do it in plastic, so it's pretty hard, but the problem is, I don't know if you guys felt it, it's a real rough sandstone type finish. The new one that 3D Systems came out as well is still a very, very rough finish. It's, I don't think it's that impressive. So the new Conex 3, and there's, we got the 13th one worldwide of the Conex 3, so we're pretty pleased with that. This was actually printed on that. I want you to pass that around, because this is plastic. We actually, one of our people painted it with some shellac and did a very good job of it. But we've only had this printer literally, we just got it up and running last week, so we've only printed a couple items on it. But a very, very cool printer. What we're hoping is that we can actually do 3D architectural models on this now. So, so you know, you've got a little better strength. The other problem, if I go back to this here, okay, so let's say I've got a railing. How do I print a railing at this scale? Remember, this is a 14,000 square foot home. It's very, very difficult, you know, if I had a flag post sitting on top of it, to actually get them to 3D print that kind of detail. It's just almost non-existent. We've done some things, we know the barriers now. So for example, when we scale down a model, if it's a 2x4 home, for example, you got 3.5 inches of 2x4 sheetrock, the outer, so you know, 4.5 inches. To actually scale that down and print it out, the walls will crumble. So we actually have to make the walls 1 foot thick, and you know, some tricks there. The difference is this here will print at 86 microns. This will print at 16. So you get about 4 times the detail. So 16 microns is about 1/6 the size of a human hair. So most of your home consumer printers will print in between 100 and 200 microns. So you can see there's a huge difference going from, say 150 on average down to 16 microns. You can do a lot with different details, and so some really cool stuff there. Questions?
Can I ask you about
Yes.
this guy?
Yes.
So the back of the cake here is like really smooth, and then there's parts where it gets rough. Was this like polished or something?
So that's one of the weaknesses. You've got what's called a matte finish and a polished finish, and so wherever, this is the general rule with the Conex and actually a number of other processes, wherever support material touches, it takes away from that finished, polished view. And the Conex, that's one of the challenges you have with that. Now, some of you may say, well, what is support material, right? I'm betting that was the next question. So think about this. If, what would be a good example? Let's say I printed this like this here, standing up, which you can do. You can print it, however you want to print it. It doesn't have to be laying flat, but I wanted to print this. Most printer technologies, the problem is I'll start at the lowest point. That's where you start printing. But the problem is when I start printing this, I have to have something that holds it up when it prints. That's what's called support material. And so support material is typically about 1/4 the cost of your actual materials, and you'll actually break it off. Maybe dissolvable, it may be washable, a lot of different technologies for that. So virtually all printers except this powder printer have some kind of support material typically. This here, it's, it just uses the powder as its support material, and then you just blow it off is what you do there. And so,
Think you reuse all that extra powder?
yes, the powder is 100% recyclable. So you've got a vacuum, and it just sucks it right back into the machine, and it's 100% reusable.
So is this a shellac or is it an acetone?
It's a shellac. Yeah, someone just went and painted it, and I grabbed it. They were just kind of curious to see what it could do. One of the other interesting things, so let me go back to your comment. You had said you were looking at the Mojo. We do have a Mojo. I don't think we've used it in about 5 months. Yeah, we've got a Fortis, a big Fortis that just runs circles around the Mojo, and
Yeah, they were basically selling it, roughly $12,000.
Right.
And it's an entry level. I thought it was pretty cool, but it's right now not for me right now.
Yeah.
My company's filing the motion.
Yeah, it's a nice little machine. We bought the Mojo and the U-Print, which are both Stratasys machines, and they gave us a pretty good deal on it. And we rarely use either one of them. Yeah, we've got a Fortis, which is a much larger machine, and we just find that's what our guys like using. A little better, a little more pricey, from that perspective. The other thing I wanted to say that if you're modeling, and you're going to find I'm probably jumping all over a lot of different topics here. When you're modeling, let me back up and say this. Every object you create has to start from a file. Now, files can be a lot of different things. So it can be a CAD file coming from a SolidWorks, an AutoCAD. It can be a modeling file that's coming from like Maya, 3ds Max Design, the list goes on. A lot of different pros and cons of the software that you use, but somehow you've got to create the file first before you can do that. What we found when you're creating your models, this is not a good example. Let me see here. It's probably, here we go. You'll see that. Notice it's hollow. Even though this one was still pretty heavy, we try and hollow out everything. And you may say, well, why? Because if you can hollow it out, you can still accomplish the 3D printing. You're going to save yourself a lot of money. So to give you an example, this here particular one, we charge 86 cents a cubic centimeter. Now, if you're an old guy like me and you don't know what the conversion is, that's about 16 cubic centimeters in a cubic inch. So go through the math. So about $13, $14 for a cubic inch. Okay, to print in this. To print this same cubic inch, On a Connex, you're probably $45. Okay, your FDM is going to be a little bit more than the Z printer. You're probably going to be about $18, maybe $18, $19 for typically a production grade. So what that tells you, you know, to print this out, very expensive. You know, a lot of people think 3D printing is very inexpensive. It is if you buy like a MakerBot, your printer, you're using the ABS, the PLA, because it's really pretty inexpensive. It's not as strong. Some interesting things there. You know, the other thing I find interesting is people think, okay, if I'm printing this, but I really want it twice the size of that. So you go from a 1 cubic inch to a 2 cubic inch, right? So your reaction is, I double the cost, right? Well, think about it. It's 3D. It's 8 times. 8 times. So going from a 1-inch cube to a 2-inch cube is 8 times the cost. So anytime you can hollow something out, you're going to save a lot of money. You know, that's something that we've found. I'd like to pass around these next. It is surprising how many companies we are printing this kind of stuff for. So how about if I'll just kind of, I don't know. How
Put it on one of those plates.
Yeah, that might be the best one. Why don't we do
Pass the
that?
plate around. See it here on that too.
Can I ask you a question?
You bet. Fire away.
So we've seen some of the models. Can you tell us more about your company?
Good question. So we are a service bureau at the end of the day. So we do 3D design and 3D printing. That's all we do. Now, how we drive our revenue is a little bit different of a model, and I'll talk about that in a second. So everything you've seen here, we designed from scratch. So even this house, you know what we took this from? I'll tell you exactly what we did, because we're actually in talks. It's one of the home design plans. We didn't get the CAD file. We didn't get the layout. We took a couple of images off their website, and our guys reproduced that. They're very good. So everything you see here today, we actually did the design work for it. And so most of our, oh, thank you.
Yeah.
Most of our design work, it was interesting, when we started the company, we thought we'd be doing all of our design work in SolidWorks. So we actually hired a number of our first few employees, SolidWorks people. What we've since found out today, probably 95 to 97% of our design work is done in Maya. Our guys like Maya. It's very fast. It's very conducive for doing things with color, and our guys really like using Maya. And so the things we're just passing around here now, you'll notice it's a different color. So this is on a different printer. This particular one is done on a ProJet 3500, which is an ultraviolet material. The actual waste that comes out of this, we have to package it up because it's toxic, and we have to do some interesting things there. We actually have to take it out, set it in the sun, let the sun harden it, then we've got to ship it off. It's kind of an interesting process. This particular printer, it's very interesting because the support material is wax. And so if you think about that, what that means is when you take it out of the 3D printer to get the wax off, we actually put it in an oven. It melts it off, it drips off, and that's what you end up with, a final product. But if you look at the detail on that, we have a lot of customers that will send us hundreds of these every day. They run businesses just doing miniatures. It's been quite interesting to me how many miniature marketplaces there are out there, and how many people are doing different kinds of miniatures in different things. And so it would almost be impossible to do about half those products in probably you just can't get to that detail on these. And so we'll use this printer a lot as well if someone's doing some things in jewelry, or they want to make a mold, for example. We'll do some things there. One of our clients, I don't know if I can. Well, I'll just mention them. I can't remember if I've got an NDA with them or not, but they actually did the Stockton and Malone statue, the bronze statue in front of the, what is it called now? I call it the Delta Center. Yeah, there we go, Energy Solutions. So they do a lot of bronze statues, and so they will actually send up something they want to produce as a finished product that they're going to actually build in bronze. And we'll actually go through and prototype out the mold, and then they'll actually do all the casting with the rubber and the resin and to get it ready for the actual bronze. So we've actually taken and saved a few steps in their process. And so really, there's all kinds of things going on. So I'm going to stop for a minute, answer a few questions. I'm going to go on to the next topic. Yes.
I used to work at a sign printing shop.
Okay.
And environmental concerns were always an issue, right? I mean, we used a lot of harsh chemicals and inks and things like that.
Right.
Is that an issue with this?
You know, not per se. So I will say this. So Invisalign. So remember we were talking about the braces. I mean, I'm not sure you guys would want to be putting that in your mouth, right? So Stratasys, for example, actually has a certified material that can be used in your mouth. And so there's all your manufacturers have different materials that are certified. The problem is, if you run that material through your printer and then you swap out for another material, guess what? You've just dirtied up the machine, and so you've got to go through a whole new sanitization and certification process before you can use that material. So typically, if you're doing that type of work, you'll find that that's really all you're printing. So, but yes?
So what would you recommend for a super entry level, just wanted to mess around with 3D printing, kind of a consumer level printer?
You know, that's a great question. And so cost always plays into that. But here's what I would tell my best friend. I would say, if you can afford it, go buy you a MakerBot. You know, they're a little pricey. You know, I'll be honest with you. They've got 6 new models. I think the low end is about $2,000 now. What I like about MakerBot, better than all of them, and this is a question you have to ask yourself, is who's going to support it when it breaks? It is going to break. You know, go back to my 75% uptime. So I talk about these 150 companies that are not going to be around. The customer service is probably lousy. So that's a question you have to ask is, okay, yeah, maybe I'm only going to pay $300 or $400 to get a printer, but who's going to be there to, you know, a year from now to support it? So that weighs into it. On the other hand, you could make the argument, well, I can go buy 5 or 6 printers for their low-end entry in a MakerBot. Their high-end is now I think it's about $6,500, which is it's a nice consumer model, but they're very, very pricey. And so I'm a big fan of the MakerBots. We've personally got a MakerBot, a Cube, and a Affinity in our office. Little 3 consumer models, and they all have pros and cons. And so I just think that's personal. What I would feel good is I would feel good telling a person, if you're going to buy a MakerBot, you might have problems, but you got someone there to support you. So, you know, I don't feel like I'm going out on a limb and saying, this is cheap printer, but yeah, I just wouldn't take that risk with friends. So.
Do you guys fiddle around with the rep wraps or anything like that?
No, we haven't. Rep wraps were very popular. You know, I mean, in all honesty, they were some of the early adopters. Here again, they're for the geeks, and that's probably half of you guys, right? The early innovators, the hobbyists, the enthusiasts, the tech enthusiasts, the guys that don't mind getting in and actually fixing the parts. If you're one of those guys, you can probably buy any one of these models because most of it's open source. You just had one copy another and put a little different twist on it. If you've got that talent, you're probably fine to buy any of them. Just realize you'll probably be doing most of the support. So, yeah. Yes.
Do you do any scanning software or technologies while you make your models, such as this house, or whatever?
So when we started our company, we went out and bought an Artec EVA scanner. And I'd spent a month trying to figure out, well, which one do we buy? There's not a lot of them. They're all pretty pricey, and so I ended up going with that. That was one of those early decisions. That it was about an $18,000 scanner. I think we've used it 3 times. We found out, I can scan any of these objects right here, and I can get them in. The problem is it just doesn't come in one piece. I mean, this is a scanner that it's supposed to automatically align as you go around. It does a pretty good job of that, but you have so much time once you take the scan and then to get it to look like this here that we found it's almost just as fast to do it from scratch. Now, fast forward a year, you've got all kinds of cool scanners. So I saw one at a show that 3D Systems is coming out with called the I forget the name of it. Probably a $300-400 scanner. I think it will probably run circles around the $18,000 one I've got. If anyone would like to buy it, I'll sell it to you at 15 grand. How about that? A great steal, right? Yes, question.
I was going to say, I think I know what you're talking about because I was looking at a handheld scanner, but if you've got like a Kinect type of device, then you can get a hold of certain programs. You can actually do the same thing. Ben Heck actually showed how to make there's people who are taking these 3D scanners and just basically just having a way to have it twirl around the person or whatnot, just with, get some wood from whatever store and basically make a support frame and then just have it scan around. Well, like you said, it's all about the software.
Yeah,
Stitching it back together.
It is. So there's been a number of businesses that have started up, opening up the little Photoshops and come in and get your picture. And here's what I don't know if I've found, but this is what I've noticed. I don't know that any of them are doing enough that how you would ever justify that being your business. I mean, in all honesty, I've probably seen 30 different business models kind of in the same sector where are doing little specialty things, and I haven't seen any of them catch on to any real volume whatsoever. So, we even did some things. So, one of the cute things we did is, you can upload your child's crayon drawing, and then we can actually take that, run it through some software, and actually 3D print out a 3D object, from a 2-dimensional. So I do the same thing with any of you guys. Send me a front image, 2 side images. We can run it through facial software and actually print out a mini-me of you guys. But I haven't seen anyone, a lot of companies doing this, but I haven't seen anyone that I think really have a sustainable business model with enough business to warrant doing that. So there's a lot of gimmick types of things, I think, going on.
Bobbleheads.
Yep, you can make bobbleheads, and so, but on the other hand, I go back to this, I think some of these guys they've actually created businesses with this here. And so, I think a lot of it is still early stage. I'm not going to be the guy that's going to predict which ones are going to succeed or fail. We took a different approach with our company that, so far no one has even come close to duplicating, and I hope they don't. But it was very much, like our last company. I guess I can't even call it Tech Media Network anymore. As of today, it's called Perch. It's Perch. It's the new branding of the company, and so we actually developed a model that is very content-driven, that drives to revenue on the back end. So at Perch now, that was all about creating content that drove to a sale, an affiliate program, an e-commerce transaction. We're doing the similar thing here, only it's driving to production of production and design services. And so it'll be interesting to see how we do in a year or two.
With those mini models, is that a finished product, or do the artists actually cast them?
Yeah, so this here could be a finished product. I am under so many NDAs, I can't tell you what we've got going on. There's a lot going on in this industry. And I'll be honest with you, going back to TNN, I have talked personally to more of Fortune 500 companies in a little 1-year-old startup than I ever did at Tech Media Network. because they're finding there just aren't many people into this, and they're trying to figure out how do they get into. So, for example, you guys have I can tell you this one. So you've probably heard US or UPS, United Parcel Service, that ships all of our stuff. So when you walk into their local stores, they've got 4,400 offices around the country. So they're in a pilot program doing 6 stores now that offer 3D printing services. You walk in, you take your file in. Staples just announced last week they're doing this as well. Well, behind the scenes, they've got a U-print sitting in their store, which they're finding people come in, they need the design services, they need something done in a different material, they can't do it. So on the back end, that's us. So we have a contract with UPS, and so they're in 6 stores. They'll probably, once their pilot's up, decide if they're going into 4,400 stores. That one worries me a little bit because that could really have a big impact on us. But there's a lot of companies that are trying to figure out how to get into 3D printing. We had a booth at CES, a little dinky 10 by 10 booth, and we were just swamped all 4 days of the show. But I was surprised at how many companies came to us. They're all brands you've all heard of. We need to be into 3D printing. We just don't know where to go, how it's going to impact our strategy. There's been a number of articles written that in regards to marketers, that if you're not thinking about how you're going to implement 3D printing into your marketing strategy, you're missing the boat. So, for example, you guys all know Disney is, let's see, I'll say everything that's public. Disney is now 3D printing at Disneyland. You can go in and get your head put on a Cinderella costume. So they're doing some marketing strategies there. Coca-Cola is now printing mini-me's. I don't understand the Coca-Cola one. I've looked at what they're trying to accomplish, and I just need to get the branding, what they're trying to tie it to. But there's a lot of big-name companies that are now kind of experimenting around with 3D printing and trying to figure out how it's going to be in their company strategy. So, questions, guys? Yeah.
So you're doing design work and rapid prototype.
We do.
You're also doing production, like you produce those old plug connectors.
Yes. So we do some end product things. Where we're headed as a company, where we think there's some interesting, is in this space right here. Home architectural. We're at the Dream Home Expo tomorrow. Starts Friday. Yeah. So if you're down there, I've got free tickets if you guys want to come down. So we'll have a little booth down there. What we have found as a business is consumers. This is still early. So I go back to my analogy, 1975, thinking personal computers. That's exactly where we're at here. So do I think people wake up in the morning and say, I'm going to go build my dream home, and in the back of their mind they say, I'm going to go get a 3D printed model. They don't even know it exists yet. Mm-hmm. I do think in time, you're building a home like this, I think you'd probably be willing to spend some money. So Park City, now there's a new requirement there that every home that goes in a couple of their building development areas actually has to have a model built of the home. Now, I know a person here in Ogden who does a nice little living making popsicle stick models of homes. So, we're hitting architecture pretty hard as a company. So we're doing some interesting thing with building architectural stuff. I can now take and download any section anywhere in the United States of a block, 2 blocks, 3 blocks, and I can actually replicate that in 3D print it. So all the buildings, it's actually pretty cool. And so if you call them, cityscapes or cityscape terrain type models, so I can actually, if I know that this house is going to go on a particular place on a lot, I can actually pull it up on Google and actually model this on the actual terrain based on Google Maps and actually combine the two. Pretty cool technology, when you think about it. So as a company, we're probably focused a little more in 3 areas: rapid prototyping, architectural, and entertainment. I don't see us getting into the medical or dental, but let me tell you, if money were no object, I think that's where I would be putting some focus. So let me tell you what's happened, which I think is the coolest stuff of anything I've talked about today. So probably within the last 4 months, let me tell you what's been announced. University of Kentucky has now announced, they've made the claim that they've actually 3D printed heart tissue that they can zap, and I'm not sure what the exact technical terms are, and actually get it to beat. Okay? They've made the claim, they believe within 10 years they will be able to 3D print an entire functioning heart with all your vascular, the muscles, the veins that could actually be put in the human body. Now, do I think the FDA will be ready in 10 years? No. But, you know, I think that's interesting. Last week, they just announced they actually 3D printed a living tumor. So they were actually able to duplicate that in a lab, 3D print it, and now they can actually start doing testing on tumors on how to kill it now, a lot faster than how they can do that. 4 weeks ago, they did the first knee transplant. It was a 3D printed. So if you go in and get a knee transplant, you know, you've got a couple sizes. You know, so a doctor will, you know, cut your leg and, you know, kind of get it in there and fit. You know, I don't know if it's extra large, medium, small. You know, but what they did here is they actually took a CAT scan, and so you can do that now. You can take a CAT scan, and we can do this. We can take a CAT scan file, an MRI file, and actually convert that layer by layer and actually 3D print out the object. And so they were actually able to 3D print customized, perfectly fit knee replacement for an individual. Let's see, what else in the medical field? 10 days ago, what was that one? God, there's so many of them now. It's the
soul that goes with the heart.
The soul that goes with the heart. Yeah, that's a good one. You know, we were actually asked by a company here last week, because with the Connex you can print out a rubber-like material. So I could actually take a scalpel and actually slice open the actual finished product. So we're actually working with a company. They would there's a new procedure. They're only doing it in South America right now because the FDA hasn't approved it here in the U.S. So it's a new heart procedure. So what they're trying to do is actually take the person's damaged heart, actually 3D print that out. The surgeons who are doing this, they can't even get certified until they've actually sat in on like 500 of these operations. It's very complex. So what they're going to do is actually 3D print the actual hearts that they're going to operate on and actually go through the process where they slice it open in this rubber-like material so they can actually do the operation as a practice run on the actual heart before they actually do it. I think that's pretty cool technology. And so, you know, you've seen where they've 3D printed portions of the liver. They've 3D printed an ear. You know, they just use stem cells. So some really, really interesting applications in the medical arena that I think, I mean, literally every week I'm reading something new. And typically it's coming out of universities, you know, the research universities, where they figured out how to do this. Cool stuff.
I saw one that the government was actually trying to do mass produce. It was funny, but it was one of those science fiction websites, but pizza. They actually have a pizza maker, and I was like watching it. It was making a pizza in a couple of minutes.
So let me talk about the food industry and the building industry for just a second. So the food industry, a year ago, I attended a conference in New York on 3D printing. You know, they had all these gurus in their specific areas, and so they actually had a cook come in and talking about 3D printing, what they had said. So here's what was his summary a year ago. He said, you can do some remarkable presentation of food on a plate. He says it tastes like crap. He said, you know, because really all of them, I mean, there's a number of models you can buy on the market to actually produce food. Most of it's in a paste type function. So you can actually 3D print hamburgers. Comes out of a paste type thing. There's one company that's doing like chips, like Dorito chips. There's a number of companies now. I think there's 3 manufacturers of chocolate things. So if you want a chocolate candy, you can do that.
They do it for commercials and stuff, right?
Yeah, yep. And so
Perfect.
3D Systems announced at CES that in the fall, and I've actually got pictures here if you guys wanted to see them, of a candy machine. So it's still the powder, kind of it's the exact same technology, the powder. So instead of using gypsum powder, it's sugar. So they actually mix it with sugar, water, and they can print out gorgeous. I mean, if you think about art, I mean, anything you can think of, they can now do in sugar that's edible. So they had some very interesting models at CES. They're doing ceramics now. 3D Systems announced that in the fourth quarter they'll have actually where you can print out ceramic objects. You still have to fire them up in the kiln, but some interesting things there. The construction industry, let me just, go ahead.
Go ahead, no, that's fine. Finish that.
So the construction industry, a lot of interesting things happening there. So I want you guys to think about this for a second. So I printed out this cool looking mansion, right? Well, okay, could I make this 4 times this big? Yeah, right? Okay, so take it a step further. Could I make it 10 by 10 home? Could I make it 100 by? Yes, you could. So the day, in China, they just last week they printed 10 3D printed homes in 24 hours to prove they could do it. In the UK, there's a company there that's built a 40 by 40 foot 3D printer, so 40 feet long, 40 feet wide, to actually do homes. So typically they're using concrete. So, they're pretty rudimentary, if you think about it. They're just laying down concrete layer by layer. They go around the doors, the windows. They do structures inside the home, like faux rock you might find. It's ideal for stuff like that. In Amsterdam, they're actually creating an entire building. They started this about 6 months ago. They figured it'll take 5 years, but everything. From walls, everything in the building will be 3D printed. The furniture, everything. Pretty massive project. So if you think about that, and I haven't talked about metal printers. So there's a process called DMS, Direct Metal Laser Sinter, DMLS. I always get those confused, Direct Metal Laser Sinter, where you can actually do anything here in metal. So you can now 3D print in gold, aluminum, titanium, cobalt. There's 3 or 4 others. Silver. And so if you think about it, in the lab here again, a couple of weeks ago, someone figured out how to come up with a material now that can be 3D printed that has better, what's the word I'm looking for electrical currents? It's better than copper. Conductivity, there you go. So if you think about that, could I see a day where they're 3D printing a home, because keep in mind, I've got a printer in Ogden that prints 150 materials now, 14 at the same time. Could they 3D print a home? Does the walls go up, where it puts in the wiring, the plumbing? Yes, I do believe you guys, I don't know if I'll see it in my lifetime, I think you guys will see that. So anyone going into the construction trades, I don't think it'll kill the construction trades. What I think it will do is change it. Because you still need people to operate this equipment, and there'll still be things like finish work and things like that. But do I think it'll change that industry? I do. So if you think about it, I've probably told you 30, 40 businesses you could start and kind of get ahead of the curve. I mean, it's all cool stuff. This is going to be a big part of our future. NASA's using it. They're planning to use 3D printers in space. They've already shipped them up to the International Space Station. They're already doing things. So, I mean, this isn't like it's just a little hobby thing. All kinds of things. So Boeing is now doing 3D printing in a number of their wing assemblies. A lot of companies using this. So, yeah. Questions, guys? Yes.
So funding. When you talk with people about money, did anybody say, go fly a kite, 3D printing all this stuff? I mean, that's the personal computer era. People didn't realize they wanted it or needed it. came out.
Mhm.
Do you have any issues with people doing funding or getting funding for your business?
You know, that's a great question. So when we started our company, we thought we'd get in early and we'd go after very much like TMN's model, go after the consumer masses. What we found is we took our site live. I think it took us, even though we had some decent traffic, I think it took us 4 days to get the first sale. It was a little $5 item. Yeah, you can't sustain a business. We learned fairly quickly that consumers are not ready for this yet. This is still a hobbyist type thing. People trying to look forward into the future, you know, willing to take some risk and some investment dollars, and you know, and the return may not be there day one. Now, I had some investors from New York fly out to meet with us last week, and I'm not looking for investors. You know, I've had a number of them contact me. No, they told me, they said, you know, there's just not many players in this, and they are going to make an investment in the 3D printing space. They had already made an offer, and the company was gobbled up last Friday by 3D Systems called, I forget their name, Fine Point? I think it was called Fine Point. Just a company very much like ours, a couple of years ahead of us, kind of the rapid prototyping. They were going to make a big investment in them, and they got gobbled up. And they said they gave them a great valuation, but it was a pretty good acquisition. So I think a lot of your investors are looking to get into it. But the big shows I've been to all around the country, what you're finding is a third of the people attending the shows are your investors, because they don't know, should I be investing in this or this? Is it services? Is it manufacturing? I don't think they know yet. I think a lot of them are still trying to figure out where do they want to put their dollars. But I think they all believe they should be investing in this somewhere. So.
The question I was going to ask was related to embedding circuits within these things, you know, to turn on the lights in the house. But kind of related to that, you know, where does the MEMS world kind of intersect with these bigger 3D printing technologies, where you go from printing at the molecular level to some of this bigger stuff? Do you ever see that kind of converging, or will those remain two separate things?
So I think, well, IBM is probably the leader in this right now. You guys probably don't even know this. I mean, you guys are in the tech space. I think most people think IBM, they're so old school, right? I mean, that's how it was 20 years ago for me when I got into computers. You're still thinking IBM is big iron. Well, you don't realize IBM, so here's an interesting stat I used to tell people. Microsoft, back in their heyday, you know, they were the world's largest software manufacturer. Software inside of inside of IBM, the division was 3 times as large as the entire company of Microsoft. So I go back to IBM. IBM's about a $70 billion revenue company. They put boatloads and boatloads of money into research. They are the leaders at the micro level. So I've actually seen images where they have printed objects down that you can only see on an electron microscope. And so they're way down in the, what would you call it, the microscopic world as far as 3D printing, trying to figure out how do they, change at the molecular level. I think you guys will see that in your lifetime. Some really cool stuff. Lots of people working on the little, the nano things that you'll actually be able to embed in the body, that'll go through and figure out what's wrong with you. How does 3D printing play into that? There's a lot of guys talking about some of that stuff. So it's early. It's early, but I give a little talk from time to time, and I go out 100 years of technology and science. I don't know if you know this. I actually went to all of our I went out to all of our editors, because they're talking to the brightest minds on the planet. And I said, okay, what do they think is going to happen? So I put together a really cool presentation, and a lot of it is 3D printing in the future. What's it going to be? So do I see a time in where in space it isn't just fixing parts in space? They may be building because they've encountered something, and you've got some rocket or a group living on Mars, for example, and they need to build something. Well, you've got to have the capabilities. It's not just a little widget type thing. I mean, it's something that's a very useful part, and I just think you're going to see 3D printing. Here again, I think it's just like the computer industry. Everything took off in the late 70s. I mean, if you go back and look at all the history books for computers, all the startups that failed, all the ones that went on, and all the ones that were on top of the world, and then they were down. And I think you're going to see that in this industry as well over the next 10, 15 years. Just some really cool stuff.
So with that, do you think there's going to be a Steve Jobs, Bill Gates? Do you think it's going to take something like that to?
I hope you're looking at the guy right here. That's what I hope for you to. That's a great question, because right now, I don't think there's any Bill Gates, Steve Jobs, any what I would call. Yeah, you've got the CEO of 3D Systems, Avi. I think he's the guy who talks at all the the shows. Do I think he's a Steve Jobs, Bill Gates? I don't. I don't think that person is in the industry yet. I just this is still an early industry. Do I think you're going to have that killer app come out in the industry? I do. What is it? I don't know.
If you do.
When we started the company, the very first thing we did is we thought, okay, iPhone cases. Everyone's buying iPhone cases. And so we went out, we figured out how to do all the different models, get the right makes, and I think we came up with like 3,000 designs. I'm still waiting to sell the first one. So what does that tell you? We did a lot of things wrong, when we first started. I mean, we've got some cool iPhone cases, some that have turning gears on them, and
Christmas
yeah,
games, right?
But I think this is still a new industry. I certainly don't have all the answers. I'm just we took our site live December 1st. We've now figured out some things that we think are going to be some good revenue models for us. Our goal is to get to profitability. We almost made it in March, almost. April wasn't as good as March, but I think give us 4 or 5 months and we'll get to profitability. So. So other questions. And I don't know what time you guys need to get out of here. If you need to shut me off, feel free.
Whatever. So what's your background? I see the little inside story going between you two. You guys worked at the same company, and then what made you decide to leave?
So I started, I started Top 10 Reviews 10 years ago, and then we changed the name to Tech Media Network. I was the founder of that company. We went through, we've gone through 4 acquisitions now, and we grew that. I mean, it's 350 employees now. You guys who won't know this, because no one in Ogden knows this. So if you look in terms of traffic, you've got Google #1, Yahoo #2, Facebook #3, Tech Media Network, or Perch, is 46th as of the last ComScore ranking. So we had 102 million visitors to our web property over there. Headquartered right here in Ogden. Most people don't even know it even exists, right?
Yeah.
I'm assuming you're still over there.
Well, have you seen the new building?
I haven't been in it yet. I've been invited. It's like I got mixed emotions,
I understand.
Yeah, so after 11 years, it was time for a change for me. But
that's why you decided to do this.
Yeah, so that was my background, and and over the years, I mean, everything we do is tech and science. And I just saw that 3D printing was really cool, and so I looked at it pretty closely. And just the more I got into it, I'll remember the day. Can I say this? Yeah, why not? If it comes out, it's okay. So I remember the day I'd gone to the MakerBot store on Mulberry Street, New York, and I walked in there, and I took my wife with me. We were out there, and I was thinking about this whole 3D printing thing, and I walked in there, and I looked around, I saw it, and I walked out thinking, this is something I need to get involved in. And I took a bracelet, and it was 3D printed. It was just a bracelet, but you could kind of turn it, and it came out of the printer all in one piece. And I thought that was the coolest technology. And so that evening we were at a party, and one of my investors in TMN, I showed it to him, and I thought I'd get the same reaction. Man, that's cool technology. He says, "Oh, what a piece of junk," you know, and his opinion of 3D printing, I think, has since changed. I think he's seen what's going on in the industry, and so even as much as a year ago, I think a lot of people have no idea where this was going to go. I mean, if you look at the stock market, if you take the last month and a half out, I mean, some of those stocks, quadrupled. A lot of people getting into the public stocks on that. I think they've kind of come back to earth a little bit, but I still think there's going to be a lot of growth there. So, any other questions, guys? Yeah.
What about the automobile industry? Have they really gotten into the 3D printing?
Yes, they are. So Ford, for example, is now doing a boatload of prototypes. That's probably where they're at. They actually have, and I'm trying to remember which part it is on one of the vehicles. They've actually 3D printed. I think if you ask them, they're still in the early stages of determining, if they go out 10 years from now, is 50% of the car 3D printed? I think that's the question they're trying to ask themselves is, where does that all fit? But they're definitely investing heavily in that. If you think about, so if you're a collector, so let's talk about this from a couple perspectives. In the automobile, I own a '75 Corvette, nice little Stingray. Love that thing. Well, trying to buy parts on that, you can't go down to the local automobile, and some of the parts are like almost non-existent. So, could the day come where you could reproduce any part on an old classic car? Yes. If you'd asked me that a year ago, I would have said probably a lot of the parts are not strong enough to do that. I think today you've almost gotten past that. So I was going to say, so you guys probably saw this. Solid Concepts came out about 4 months ago, and you guys remember all the hype about the gun, 3D printing guns, the plastic guns. What Solid Concepts did, because they're big into the the metal 3D printing, they actually 3D printed a replica of the Colt 1917 Colt pistol. So it was a replica. They actually reproduced the gun and reproduced the bullets to match the gun. They shot over 500 times. I mean, it worked. So if you think about that, what they proved is you could reproduce any weapon ever produced in the history of mankind, even if it doesn't exist today. You could reproduce the bullets or whatever the mechanism is inside. You just have to put the gunpowder in. But I mean, if you think about it, from a replica perspective, I think there's a whole industry there waiting to just jump on board. I've got a second home in St. George, and if you look on one of my walls, I've got about, 50 swords. I'm just kind of a collector of. I think they're cool to own, and I suspect. I mean, think about that. You've got replicas of swords and all these, the flanges and the little balls, and I mean, people are building that because there's a demand for that. Well, I don't think anyone has ever even thought of, could I reproduce an old gun from the Civil War or from, and ones that actually fire, that you could actually, I mean, that is an industry that I don't even think anyone's even touched yet. And so they're selling that gun, if you want to go buy it, I think it's $17,000. But yes.
It kind of brings up, maybe I just think through it, but I start thinking, do you think it'll get to the point where you could fraudulently duplicate some artifact or something, or we can start seeing 3D printing fraud down the road, forgeries and things?
Oh, well, that's a great question. I'm trying to think, okay, so what would be an example? Could someone 3D print, I'm just trying to think what it would be. Money? I mean, you can do that with copy machines, I mean, the treasury
like a rare base or something. gem that's been lost for a long time, so you have to find it.
You know,
It exists.
Do I think they could reproduce them? Yes. Do I think the experts could figure out fairly easy if they're real or not? Yes, I think they could do that. Now, you know, I'm a true believer. I think, you know, the days of the replicator on Star Trek, I'm not so sure that that couldn't be done. You know, pretty close. Probably not exactly how they portray in the movie, but, you know, do I think that day could come? I think so. I really do. Yeah, it's a very slow, cumbersome process today. But if you look at how computers operated in 1975, I mean, think about it. I mean, that was just as slow and cumbersome. You know, my first computer held 4K of memory, not 4 meg, 4K. 4K. I had to save it on a cassette tape. I don't even know what cassette tapes are, right? And so, you know, you look back at where we were in the computers, and, you know, if you fast forward in this industry 20, 30 years, I think you're going to see some remarkable things. And so I think there's lots of opportunities. I think it's trying to really figure out, though, what is the right opportunity, and can you turn that into a sustainable business model? I think those are some of the challenges. But
Probably going to print our computers in the future.
what's that?
I said probably be able to print our laptops.
You know, that wouldn't surprise me. You know, there's a lot of talk on, can I 3D print an actual circuit board? You know, once they get that down, yeah, I think the rest is going to be. But then on the other hand, you may argue, will that device even exist in 10 years?
That's true.
You know, there's a lot of talk, you know, with the new wristwatches, and is that the next iPhone killer, or, you know, the smartphones? You know, I think, you know, if you look down the road, you're going to have devices. I think holographics is going to be another huge thing. There's a lot of work going on in that, and so I don't know. I love tech. Can you guys tell? It's a great field to be in. And, you know, I think most of you guys are in the tech space, and you know, I sometimes think people get hung up, and they work in their little corner, and you know, they do a good job of that, but they don't look at the whole big picture. A lot of cool stuff in tech. You can tell I'm a big STEM, you know, science, technology, engineering, math, you know, in high schools, and you know, because I just think there's some really, really exciting stuff, you know, coming down the road. And you know, and if you follow it closely, I mean, you can see just new announcements every single day. Cool stuff coming along, and you know, sometimes I think you get hung up as like a programmer, and you're a PHP programmer, and that's all you do. You know, and you know, there's a lot more to the world than just, you know, than just that one aspect you're working on. Nothing against PHP. I think PHP guys are great. They're always in demand, and a lot of cool things going on there. Any other questions, guys? I don't want to take your whole day. I can talk all day on this, but you know. Okay.
All right, thanks, Jerry.